Hello everyone, welcome to Chapter 8 on Cognition, Language, and Intelligence. In this chapter, we're going to talk about what cognition is and how our cognitions are organized by concepts and different types of concepts. Our fourth objective we're probably going to get through pretty quickly because it's, for the most part, is a review of some stuff you learned back in the biology and behavior chapter, but now looking at those that particularly pertain to cognition, language, and intelligence. We're going to cover how we solve problems and make decisions, and we're going to learn about different approaches we use. So what is trial and error, what is algorithms, what are heuristics. We're going to define language and talk about how language, having a word for something, can impact how you think about that concept. And then we're going to talk about intelligence with some various theories of intelligence. And I'm going to warn you now that I'm going to introduce some concepts that I'm going to hold you accountable for with regards to theories of intelligence that are not covered in your textbook. For the most part, I really love this textbook, but the one exception is when it comes to theories of intelligence, because they leave out what is the most modern and empirically validated theories of intelligence that modern day intelligence tests are based on. So I'm going to teach you about that, even though the textbook doesn't address it. So we're going to learn about some intelligence tests, how intelligence is measured, and then we're going to end with creativity. So our first learning objective is to simply define what cognition is and how it relates to thinking. So cognition is a very broad term. It pertains to anything that's going on inside your head that is involved with obtaining, converting, and using knowledge. So when we first defined what psychology is, we said it is the scientific study of human behavior and mental processes. So cognition is dealing with that mental processes component of it. Those activities that we can't directly see that are happening inside your head that deal with using knowledge, getting knowledge, converting the knowledge you have. It's a very broad term. Thinking is just one type of cognition. It is the type of cognition that uses information to reach a goal or to make a decision or to come with some solution. So thinking is just one type of cognition. So in this picture, you've got a civil engineer here in the process of building a bridge. Reflect for a minute on the various type of cognitions this guy might have related to his job. So what do you think might be going on inside his head that involves with obtaining, converting, and using knowledge? The next objective is to understand what we mean by concepts and to know how concepts are organized. So we learned back in our perception chapter that the brain does not like random, that we are always looking for patterns and organizations. It applied to how we organize and interpret our sensory information. In this chapter, it also applies to how we organize our own thoughts, our own cognitions. So once you are able to represent something in the real world in your head, we represent them in terms of concepts, that things that are similar, events, ideas, objects, we sort of group together. And that mental grouping of things that have something in common is what we call a concept. Our concepts are organized in hierarchies. So different categories of putting things in. So let's use the basic concept of an apple. That is what is known as a mid-level concept. There's a broader category, a broader grouping. That's what we call the superordinate level. So an apple is just one type of a broader concept, which is fruit. And then we can get the subordinate or specific level concepts. So here in Michigan, where people visit the apple orchards in the fall, I'm sure you can think of lots of very specific types of apples. So Macintosh and Granny Smith and Gala and Fuji and Honeycrisp, and all of those are specific or subordinate level concepts. So now we're going to learn what's the difference between what we call a formal concept and a natural concept. Now, some things, some categories that we use to group things in, they have very, very rigid rules that define that category. It is an all or nothing thing. It either has all of those criteria and we group it in that conceptual category, or it's not. So, for example, a triangle would be an example of a formal concept. It either is or it isn't, and we can tell somebody specifically what are the criteria that define something as a triangle. So we can say it is a shape that has 3 sides and 3 angles, and the angles sum to 180 degrees. If it doesn't have those criteria, then it's not a triangle. It is or it isn't. That's what's known as a formal concept. Now, a lot of the things that we conceptually organize don't have such rigid rules. We can't tell somebody every single criteria that would make something part of that conceptual grouping. You simply have to learn it from experience. And that is what we call natural concepts. Natural concepts are things that they have enough similarities to hang together for us to group them together, but the boundaries between what is in that category and what is not are sort of fuzzy. So here you have a robin and a penguin, both of which invariably people would group under the concept of birds, but they don't have every single thing in common. There's enough in common that we want to group them together, but a robin flies and a penguin doesn't. So not everything, not every criteria about them is the exact same. This is what we term a natural concept, something you just have to learn from experience. So when we have natural concepts, because there is variability among the various things that we would group together in that conceptual category, we still have a way of, in our minds, representing that whole concept. And that is what is termed a prototype. So we were just talking about the natural concept of birds. There are lots and lots of different species of birds. every one of those species that you would put in that conceptual category, we call an exemplar. But when I say birds, something comes to mind for you that represents that whole category. A particular type of bird comes to mind, and that is what we would call your prototype, the most typical or best example of that whole natural concept. So let's consider another natural concept. If I say the natural concept of fruit, what comes to mind? How do you represent that whole category? Most people would probably think of an apple, an orange, some common type of fruit that you use to represent that whole category. But then there are lots and lots of different types of fruits that would be the individual exemplars. Now we're going to revisit the idea of prototypes shortly when we get to problem solving and decision making using heuristics. There's a type of heuristic, which we're going to learn is a mental shortcut that we use that relies on the prototype. We think of an example that represents a whole category of things that are quite variable, and we expect anything new we encounter to sort of match up to the prototype. And later in the semester, when we learn about social psychology, we're going to see we do the same thing with people, and that can result in a problem that we call stereotyping. People are a natural concept. Different races of people are a natural concept. There's lots of variability, but you still have a way of, in your mind, representing that whole category. So you meet somebody new of a particular group, of a particular race, and you match it up with your prototype and you assume that it should match. Yet, sometimes we fail to remind ourselves that there's a lot of individuality, a lot of uniqueness in the individual exemplars, especially when you get to talking about people. So prototypes are very helpful in thinking of a broad natural concept, but we have to remember that that prototype does not necessarily represent every single example in that natural concept category. Now, another type of cognition is imagery. So for all our senses, we can represent what we take in with our senses entirely, through mental activity. And that is what is known as a mental image. Research on mental images tells us that when we represent something in our minds through a cognition, that we use those same mental images as we would the actual thing that we would take in with our senses. So what do I mean by that? Let's use as an example this map. So they recruited people for a study, randomly put them into two groups, and gave them all this map. One group was told, I'm going to ask you some questions about navigating to different places on this map, and you're going to have the map in front of you to refer to as you answer. Another group was told, I'm going to ask you some questions about navigating to places on this map, but I'm going to have you first study this map until you have it memorized and you can picture it in your head. And what they then did was ask both groups of people how to navigate to different locations on the map, and they timed their reaction time. How long did it take them to navigate that area of the map? And they found that whether you were using the actual map or the map in your head, the mental image, that the times were almost identical. So if I asked you how to get from the beach to the rock over here, that's farther away. It should take you longer to travel that map, whether it be the map on paper or the map in your head, than it would if I were to ask, how do you get to the beach to the hut over here? We have imagery for all of our senses. So you can represent sensory experiences in your head without actually experiencing the sensory experience. And that is what gives us such joy and pleasure from reading, because you can imagine and picture and represent in your head the kinds of things you are reading about. Visual imagery is pretty common. If I start, talking about a blue sky, you're able to picture an image of a blue sky in your head. But we have it for all of our senses. If you get, a song stuck in your head that's not really playing right now, that's auditory imagery. If I start talking about your absolute favorite food and you can almost smell it and taste it and your mouth's watering when it's not really here, that is imagery. If I start talking about how there's a lice outbreak in your little sibling or nephew or niece's elementary school class and you start itching when there's nothing to itch you, that is imagery. So we have it for all of our senses. Now this is the objective I told you that we're going to be able to cruise through very quickly, because this is all stuff you already learned in past chapters. So describe the biological processes associated with cognition. So in this chapter, we're going to be talking about making decisions, solving problems. A lot of that kind of stuff is frontal lobe executive functions. You learned that in chapter 3, that your frontal lobe is responsible for all of those higher cognitive functions. This chapter also deals with language. You know from the chapter on biology that we're dealing with left hemisphere things then if we're dealing with language. Hopefully you remember there are two main language areas in the left hemisphere. So we have Broca's area in the frontal lobe of the left hemisphere for language production. We have Wernicke's area in the temporal lobe for language comprehension. We were just talking about visual images and auditory imagery. If we're dealing with visual imagery, we're activating the visual cortex in the occipital lobe. If we are dealing with auditory imagery, we're dealing again with that auditory cortex in the temporal lobe. You learned very recently in the chapter on memory that the biological basis for memory is long-term potentiation. It is pathways of neurons growing more places where they can form synapses, making those neural pathways more efficient. All right, so the next objective is to be able to explain trial and error and algorithms. So in order to do that, we need to first start with the idea of problem solving. It doesn't matter what approach we're going to talk about, and we're going to talk about 3 approaches in this chapter: trial and error, algorithms, and heuristics. Doesn't matter what approach we're dealing with, the problem-solving process is the same, where the initial step in the problem-solving process is to even identify what the problem is. What am I trying to accomplish here? What is the goal? And then from that starting point, you choose your approach. And we're going to see, depending on what the problem is really going to determine what approach you use. Some problems have a very specific way of solving them that we would call an algorithm. Sometimes there might be a specific way of solving it, but you don't know it, so you have to try different things until you find one that works. Sometimes you just use some general strategy or some shortcut that usually works, but is not guaranteed to work. That's what's known as a heuristic. And then once we choose an approach, then the final step is check it out. Did I accomplish what I intended to accomplish? Did I solve the problem? Did I accomplish the goal? If so, great, you're done in the problem-solving process. If not, then it becomes a cyclical process and you have to cycle back through and see, where did I go wrong? Maybe I didn't fully understand the problem to begin with, and that's why I didn't solve it. Maybe I understood the problem, but I chose the wrong approach. So now I have to choose a different approach. So it doesn't matter what problem we are addressing here, we're going to be following the same process. So the simplest problem-solving process is trial and error. You just try different solutions and you eliminate the ones that don't work until you're left with the one that does work. So imagine, you've got a ring full of keys and you don't remember which one fits the lock you're trying to open. So you're trying each key until you find the one that works. That is trial and error. It can be very time consuming sometimes, not often the most efficient way of solving a problem. Now, other problems have algorithms for solving them. An algorithm is a formula or a set of rules. What makes algorithms special is that if you know the algorithm and you do it exactly like it specifies, you will always end up with the same correct solution. So you probably think of algorithms readily when you're thinking of things like math formulas and formulas in, different sciences that you already know. But a lot of things can be considered an algorithm. So if you buy, a furniture that you have to assemble, like furniture from IKEA, the set of instructions is an algorithm. If you follow them step by step, you should always end up with the same accurate assembly. So those set of instructions could be considered an algorithm. Or if you cook or bake and you follow a recipe and you do the exact thing that the recipe tells you with the same ingredients, with the same measurements, you should always end up with the same product at the end. That recipe is an algorithm. An algorithm could also be something like a flowchart, where if you follow it and do what it says, you will always end up with the accurate solution. So let's check in with one of our favorite scientists, Dr. Sheldon Cooper, and look at his friendship algorithm. Might be silly, but still an example of an algorithm. So I encourage you to pause me and click the link for the video for a little amusing break, but also an example of algorithms. Now, algorithms are great. If you know it and you follow it, you're always guaranteed to be right. However, in everyday life, you are making countless decisions on every single day, and life doesn't always come with a set of instructions. And that doesn't mean you can, you know, not make a decision. You still have to. So sometimes we use what are known as heuristics. They're mental shortcuts. They're little strategies that we use to narrow down the possible solutions. They're not guaranteed to be right, but they improve our chances. So here you've got a guy at the store, and while he's there, he gets a call from his significant other and says, "Honey, can you pick up some acai berry juice? I hear it's really good for your antioxidants." And he's like, "Okay, I don't know what the hell an acai berry is, but I'm going to start by looking in the juice aisle." He's using a heuristic. He's not going to be guaranteed to find it there because he doesn't even really know what he's looking for, but he's narrowing down his solutions. Others will say sometimes the solution just sort of comes to you, and what they will refer to as a flash of insight. You know, the light bulb goes on inside your head. Well, that's not really a strategy. And is insight possible? Well, yeah, because we know from past chapters, your brain never shuts off, even while you're sleeping. So you might think, I'm not actively thinking about this problem, but maybe your brain is still working it out subconsciously or automatically, and suddenly you come up with a solution in a flash of insight. Now let's talk more about those different types of heuristics and how we use them. So again, a heuristic is a rule of thumb, a mental shortcut, and we use them in particular situations. We use them when we don't know what else to do. We don't have an algorithm. We use heuristics automatically. Most people are not thinking, oh, I'm going to use a heuristic. I'm going to use this mental shortcut. No, it just automatically happens. We use them when we don't have all the data. We don't have all the time, but we still have to make a decision or come to a solution, or maybe we're just not motivated to give it a whole lot of mental energy. So a heuristic is a way of still making a decision, and they usually work out pretty well, but we have to remember that they're not guaranteed to be correct. So there's a couple of main types of heuristics that we use. The first is known as the availability heuristic. This means that we use something to solve a problem or come to a solution just because it is available to us. It is ready to think of an example. Now, just because you have an example ready in your mind and very accessible to you does not mean it is necessarily the right thing in this situation. But again, we use these automatically, and for the most part, they serve us well and work out okay. But consider this example. So they brought in people for a study, and they asked these strange questions that you probably would not know the answer to unless you were some kind of death statistician or something. And they still demanded you give them an answer, and they gave you a time pressure. So giving you all of the necessary conditions for which you would use a heuristic. You don't have all the information, don't have a lot of time to think. So it asks people these strange questions. What do more people die of? Shark attacks or falling airplane parts? Tell me the answer now. Well, most people would very easily think of examples of shark attacks because when they happen, you see it on the news. You're like, okay, I saw Jaws, I saw the Meg. I would guess shark attacks. When actually, if you look at the actual statistics, shark attacks, as dramatic as they are, they're relatively rare. You are far more likely to die from a falling airplane part than a shark attack. And what you really should fear more than the sharks are these dudes, the cows. Cows kill 10 times more people than sharks do in any given year. They're big. If you are a cattle rancher or something, they're big, they're clumsy, you got a lot of them. If they step on you or stampede you, you're a goner. So the availability heuristic means that we predict the probability of something happening now based on how easy it is for us to recall something similar. Now, again, just because something is easy for you to think about does not mean it's the right thing in this situation, but we still use it. In most situations, they don't have, big life or death consequences, but they could. So think about the last time you went to the doctor. We put a lot of faith in our medical professions, and I'm not bad-mouthing them. I definitely think we should listen to them. But we have to realize they're humans. They fall victim to heuristics, and heuristics are not guaranteed to be right. And consider the circumstances under which you go to the doctor. How much time does that doctor actually spend with you in the office? Maybe 5-10 minutes if you're lucky. Yet you still expect to leave with some diagnosis or prescription or treatment. And then what kind of data do you take them? Most people aren't going in with, okay, doc, here is my blood panel workup. Here is my blood pressure that I've been keeping track of the past 3 weeks before my appointment. No, you're like going in there with some vague stuff. You're like, oh, I don't feel good. My tummy hurts. Doctors are likely to rely on the availability heuristic. Oh, this symptom makes me think of this disorder or this illness. Well, who knows why that's easy for them to think of? Maybe they just went to a conference and that was a topic of one of the sessions they attended. Maybe it was the topic of a journal article they just read. Maybe it was something a pharmaceutical rep was just talking to them about, and it's on the forefront of their mind. And, they try to match it up to your symptom presentation, and it may or may not be correct. Another type of heuristic is the representativeness heuristic. Again, this relies on your prototypes. So when we use the representativeness heuristic, that means that a prototype is popping up in our head, and we are assuming this new thing we're trying to make a decision about is like that prototype. So here's an example of using the representativeness heuristic. Again, brought people in for a study and told them, we're going to play a game. I'm going to read you 100 brief descriptions of people, and I want you to guess their occupation. Are they a lawyer or are they an engineer? You need to answer as quickly as you can, and your objective is to get as many correct as you can. And they tell you going into it, I'm going to read you 100 descriptions. 80 of them are attorneys, 20 of them are engineers. And then they start the game, and you hear a description like this. People consider him sort of nerdy, he's into computers and science fiction. What's his occupation? Now, if you're like other people, most would say he sounds like an engineer to me, because you got this prototype of engineers being these really smart, nerdy science guys. But let's remind ourselves of the rules. They already told us going into it, 80 of them are attorneys, 20 of them are engineers, and our job is to get as many right as we possibly can. We're ignoring some very important data there. If we want to get as many right as we can, we literally could have just blocked our ears to everything that was said in the description and always answer attorney, attorney, attorney. But most people don't. They will rely on their representativeness heuristic and assume the guy is an engineer because it seems to match my prototype. Another type of heuristic is known as the means end analysis. This is when we think of what do we have to accomplish? What is the end goal? And then what's the easiest way for me to get from where I am starting to what I need to accomplish? Well, the distance between your initial state and the actions you have to take to get there that you think of are not always necessarily the best thing. You know, in an online class, if your end goal is, I just want an A in this class, well, the shortest way to get to an A might not be really the best way to learn everything. So it's not, again, guaranteed to be right. So an easy way to get an A might be to cheat, to talk to somebody who had that class in the previous semester and get all the answers, and you do only the bare minimum that you have to, and you accomplish the goal. But again, it's not guaranteed to be the best solution, which is why it is considered a heuristic. All right, so now let's talk about what are some of the common obstacles to problem solving. As an example, we will use this, which was used in a famous study. Brought in people for a study and they said, here is your problem. You need to come up with a way to safely mount these candles to the wall of a dark room so that you could light the candle and light up the room, but you do it safely so that the wall is not catching on fire. And this is all you have to solve the problem. These are all the materials you have to use. So think for a moment about how you could use these objects before you to solve that problem, to safely mount the candle to a wall so you could light up the dark room without catching the wall on fire. So did you think of the solution? If not, you might have fallen victim to one of the most common obstacles to problem solving, and that would be either fixation or mental set. So the accurate solution, the best solution to this problem, is to empty the matches out of the box, to use the thumbtacks to tack the box to the wall so it is sticking away from the wall. You could use some thumbtacks from underneath the box so you can stand up the candle and thumbtack it so it stays standing up. You could even light one of the candles and melt the bottom of one candle so the wax will also help it stand up. And then you light the candle and you now have it safely sticking far enough away from the wall that you're not going to burn the wall. Many people who don't solve that problem that way probably were engaged in functional fixedness or fixation. The inability to see something from a new perspective, seeing the use of something in only one way. So people know I got to use the matches to light the candle in the end. So they see the matches as something they need to use in the end, and they fail to see, well, the box itself that's holding the matches could be part of the solution. That could be part of solving the problem. Another common obstacle to problem solving is getting stuck in a mental set. A mental set means you did something in the past sort of similar that worked. And now, even though you're in this new situation, you use what worked before. And what worked before might not be the right thing to do in this current situation. All right, our next objective is to talk about how we make decisions, and specifically how those heuristics we just learned about can sometimes lead us astray because they're not guaranteed to be right. All right, so there's a few different models we can use to make decisions. For the sake of example, let's say that the decision you're trying to make is you're trying to decide on what apartment to rent. So one way you could do that is by using what's known as a single feature decision-making model. So you're simplifying your decision by focusing just on one feature of the decision, hopefully the one that you find the most important. So going into an apartment hunt, you have a wish list of things you're looking for. So you have a location that might be desirable. You have a price range in mind. You have options of, entry level or a second floor. You have a 1 or a 2 bedroom, the option for a carport or not, or whatever. Single feature would mean you focus just on one of them. You're like, okay, what's most important to me is price. This one's got the price I can afford. I'm going to go with that one. An elimination by aspects model means that you're evaluating all those apartment choices, comparing them to, again, your wish list of all of those features that you want, and you start eliminating those that don't have the kinds of things you're looking for until you're left with just one, which would be your best alternative. If you've never gone apartment or house hunting yet, I hate to burst your bubble, but I'm going to tell you now, you never find everything you're looking for. The final way you could make a decision is by doing what's known as an additive model. So in an additive model, you're making your decision by evaluating the individual aspects of each of those choices of apartments you have, and you're sort of scoring them, sort of adding up the pros and the cons. Which one has more pros? In the end, that's the one that you go for. So how can heuristics lead us astray? What are some of the potential problems we encounter when we rely on heuristics? So remember, The representativeness heuristic means we're relying on that prototype. We have a way of representing that whole concept in our head, and we're judging the likelihood of something new matching up to our prototype. Well, again, when we're using the representativeness heuristic, we might be ignoring other data, that base rate data, like in the example where you knew there were 80 attorneys but only 20 engineers. It also can lead us to sort of forget that everything is unique, especially people, so they don't necessarily match up to your prototype. The availability heuristic, again, relies on how easy is it for me to think of an example. The biggest problem is just because you can think of a vivid example does not mean it's necessarily the right thing that applies to this current situation. So when we rely solely on heuristics, we can make some errors. Here is some data from another study that was done shortly after a highly publicized terrorist attack. And they asked people shortly after that attack, what do you think is your risk of traveling to the Middle East right now? People who were using the availability heuristic thought it was really more risky than it really was. And they judged the risk to be rather high risk. And then they showed the people the actual data. You can see it's very unlikely someone's going to die from a terrorist attack. What you should be really concerned about is simply, driving to school and work, because auto accidents are still the leading cause of death. Again, let's think of, modern times with the pandemic. Let's say you're in the grocery store and somebody next to you suddenly starts coughing. What is likely popping into your head? You're probably thinking, oh my God, this guy's got COVID-19. There could be a lot of reasons why somebody is coughing. You don't have, you didn't do the nasal swab. Certainly can't get instantaneous results. So you're going with, okay, the COVID-19's on my mind. That's easy to think of. So I'm going to assume that's what he's got. And you could be wrong. That's the point about heuristics. Don't lose sight of the fact that you could be wrong. What are some other pitfalls that can impact our decision making and our problem solving? One of them is known as the confirmation bias. Confirmation bias means that whenever you have a decision to make or a problem to solve, even if you're not fully aware of it, you have some preconception about what it likely should be and how it should turn out. Confirmation bias means that once we have that preconception, we tend to look more for and pay attention to things that say, yes, you're on the right track. Yes, you made the right decision. And we tend to ignore information that would suggest to us that we're wrong. We also tend to have an overconfidence bias. As humans, we don't even really like to think that we could be wrong. We like to have a lot of faith in our decision-making ability, and sometimes that can result in problems, not even recognizing when we're wrong. And when we're wrong, we are not very quick to abandon our wrong beliefs. That's known as belief perseverance. So even after your initial conceptions were proven wrong, we might say to ourselves, well, I still sort of believe this, but this is like the exception, especially when it comes to people. If you've got like some hard prejudice about somebody and then you encounter somebody from that group that doesn't quite match, most people won't automatically abandon their prejudice. They will have this belief perseverance and say to themselves, well, I still sort of think this about that group of people, but this guy, he's maybe the exception. And hindsight bias. We talked about this, I believe, in a previous chapter when we were talking about things like the scientific method. After something's done and you already know the answer, we tend to fool ourselves into thinking, yeah, I knew it was going to be that way all along. I knew it was going to turn out that way. That again is known as the hindsight bias. All right. What other things can influence our problem solving and our decision making? So for sake of example, let's use this. If you are somebody with an undeclared major and you don't know what you want to be when you're done with school, here's a profession maybe you have not considered. This here on your screen is a chicken sexer, a vital role for folks like who are poultry farmers. Their job is, as soon as possible when the eggs hatch, to identify which ones are the boy chicks and which ones are the girl chicks, which ones are the hens, which ones are the roosters. Now, personally, I've never tried to look at baby chick genitalia, but I've been told it's not easy. You can't easily tell. But if that is your job, if you've been doing that for a long time, you're probably really good at it. And that is what we sometimes refer to as intuition. Sometimes we've got like this gut feeling. Sometimes we even think it's something magical where it really doesn't have to be. It could simply represent that this is something that I'm so good at now. I'm so accustomed to. I've been paying attention to for so long that now I can make these kind of decisions without even being fully conscious of exactly how I'm doing it anymore. So think of things that maybe you might consider as intuition at this point. Are there things that maybe you have gotten so good at that now you're able to do those things and make those decisions without even really maybe being fully aware of how you're doing it? Now, sometimes our decisions can be affected simply by how the choices are presented to us, how a question is worded, for example. So we talked about the misinformation effect in our memory chapter, how somebody's insistence on remembering something was impacted simply by how they were questioned. The same kind of thing can happen with our decision making. So let's say, for example, you are in the supermarket trying to decide on what package of ground beef to buy. And your options are, should I buy this one that is 75% lean, or should I buy the one that is 25% fat? Most people are going to go for the 75% lean. But if you stop and think, they're functionally equivalent choices. But if your choice is influenced simply by how the choice was presented to you, then that is what is known as the framing effect. Now, in our chapter on memory, you were introduced to the disorder, CTE, chronic traumatic encephalopathy. We touched upon it in that chapter because it is something that can affect our memory, but we can revisit it in this chapter because it does affect the broader things of cognition, language, and intelligence. So again, CTE is a relatively recently discovered disorder. That's a neurodegenerative disease that we find in people who have sustained head injuries, blows to the head. So playing high impact sports, combat vets, folks like that. Again, we're not talking about splitting your head open, lacerating the brain. We're simply talking about these closed head injuries where you have some head trauma. And at the places where you have that trauma, you start accumulating that tau protein, which is the protein that was also implicated in Alzheimer's disease. And again, in CTE, again, because your head is floating, your brain is floating within your skull in cerebrospinal fluid, I might get hit on this side of my head, but the impact causes my brain to shift to this side of my head and hit the inside of my skull. I could also end up with that protein accumulating on the side opposite of where I was hit. It is a neurodegenerative disease, which means it's going to get progressively worse. Typically starts with minor things like headaches, but then it progresses to changes in mood, irritability, and as those proteins start accumulating, you will end up with cognitive problems thinking, speaking, making decisions, solving problems, very much like you would find in dementia like Alzheimer's.